In C++, we have a lot of syntax and concepts that have been inherited, so to speak, from the C programming language, which predates C++ by over a decade. So we're talking 1970s. The syntax for built-in arrays has mostly remained the same in C++ and is very popular. Let's look at a diagram of an array to better understand it. So an array looks something like this. The array has a single name, but it is divided into cells, each of which can hold a piece of data. The array must specify a data type to hold. Each cell within the array can hold a piece of data with that data type. So we call that homogeneous. The piece of data that lives in the cell in an array is called an element of the array. The means by which we identify where an element lives in the array is by the element's index, the plural of which some people would say indexes, but I prefer to use indices, I-N-D-I-C-E-S. Arrays, again, in C++ as mentioned, can hold data at each index inside each cell of a specific type, but that type must be the same. Also, when you declare an array of a certain size, the memory that is allocated for all the data is contiguous in memory. This means that all the allocated bytes in memory are adjacent to one another. So you can look at the little diagram we have here that I'm pointing to, and you can see also code to the left and then the diagram to the right. And you can see that the diagram has 5 cells in it. You'll notice that the cells are indexed starting at 0, and then they end at 4 in this particular example. You'll notice that it has the number 12 at index 0, the number 5 at index 1, the number 32 at index 2, the number 17 at index 3, and the number 2 at index 4. So another important characteristic of arrays is that they are fixed size. Once you create an array, you cannot just tack additional elements onto the end of the range that was allocated. In memory, you don't know what might live at the memory beyond the boundaries of your array. You'll remember that we allocated it as a large contiguous chunk. So we can't just add on to the end because we do not know if the memory beyond that boundary might belong to something else. So let's look at some code together. I'm going to create a new project and we're going to call it Array Fun. So empty project C++, we're going to call it Array Fun and hit create as usual. And we're going to fill in our skeleton code that we always have. Okay, main.cpp, right here, include iostream, using namespace standard int main, and return 0. So I'm going to declare an array here. I'm going to call it my array. This one won't be identical to the one in the slides. It will be very similar. The size of the array is indicated at declaration of the array, and it's known as the size declarator. So right here, we have this number 5 right there. So here we're using a literal constant, 5, but we could also use a symbolic constant, for example, array size. So I might make a const int, array size, and then instead of this 5 here, I'll just use array size. So that value, whatever you use, whether it's a literal or a constant or whatever, it has to be known at compile time. In other words, using this syntax for declaration, you cannot obtain the size at runtime, say from the user entering it with the keyboard. To access individual cells within our array, we use the subscript operator, also known as the array index operator. So we can retrieve data and in most cases change the data using this operator. So let's look at some examples. So I can set my array at 0 equal to 15, my array at 1 equal to 20, my array at 2 equal to 22, my array at 3 equal to 13, my array at 4 equal to 6. And note that the lowest index is 0, and that we go up to the highest index, and that highest index is the array's size minus 1. This is an important aspect of arrays that you must remember. In computer science and software engineering, we usually count starting at 0 instead of 1. So I would say the first element is actually 15, but it is at index 0, not index 1. You'll notice that the ramifications of this are not just that it affects the beginning, but it also affects the end. So the implications are that the highest index I can use is a 4 instead of a 5. And no matter what the size of the array is, if the size were 100, I could go up to 99, but I cannot access index 100 because that would not belong to my array. It would be memory outside the bounds of my array. We can iterate through these arrays using a loop. Let's use a for loop to loop through or iterate through our array. So I'm going to put for int I starting at 0, which is the lowest index, I less than array size, and I++. And in here, I'm just going to say cout, and I'm going to use my array at I. That's how I read it, is at I, okay, using the subscript or array index operator right here. You'll notice something interesting about the for loop in that I have the variable name I. Now, in most cases, we would want to use a much more descriptive name for a variable, but with for loops especially, it is very common, again, to use I and J and K and things like that. So we learned that when we discussed repetition control statements, but I thought I'd remind you. So we can also, besides doing this, if we want to run this and see what it does first, let's do this before we get ahead of ourselves. Okay, good. And it goes through the array. If you'll think about what it's doing, the loop is incrementing this I value here. And every time it goes through the loop, the I has a different value. So the first time through the loop, I is 0. So it prints out whatever's in my array at 0. So just like I'm assigning it as the left hand of the operation here, I'm using it here to obtain the value, not change it. So it goes through and gets to 15, then I is a 1 on the next iteration, so it prints out a 20, then a 22, then a 13, then a 6. And then when I is equal to 5, it does the test 5 less than 5, and that's false, so it breaks out of the array and does not try to access index 5. Excellent. So we can also declare an array with an array initialization list. Instead of going here one by one, I can, let's make an array of strings. So I'm going to include the string library as well. And I'm going to put it up here. And we're going to use a string array numeric literal this time. So names at 4. And I'm just going to put some names here. So Bob, Sally, comma, John, and then comma, Ed. All right. So these are the names that I have here, and this is the initialization list. You notice instead of going directly into a semicolon here, I have a set of curly braces with some values inside. And it can infer the size here, but I've indicated it. The size is 4. So Bob, Sally, John, and Ed. And let's go through here and print this out. So let's say for int I equals 0, I less than, this time I'm going to use 4, and then I++, and I'm going to print out names at I. Now you might be a little confused, why or how can I use I in these two different locations? And the answer is scope. We've briefly discussed before, the scope of this variable right here is just in this loop. So if I reuse it somewhere else in another loop, then that's okay because these are two separate scopes. Now if I declared the variable out here, then we would have a different situation. But this is what we need right now. So let's see what happens, and it should print out the value at the index 0, 1, 2, and 3. So you should get Bob, Sally, John, Ed after the printout of the integers here. So let's see what happens. And we do, in fact, get the numbers, and then we get Bob, Sally, John, and Ed. So what if we forget that the bounds of the array ended before the size of the array size, on, say, our integer example right here? So, for example, what happens if we change this to less than or equal to? Maybe we think it goes up to the array size. Let's run it again and see what happens. You'll notice that we get some really, really weird number here, right? In some cases, this program would actually crash. You would actually see an error pop up, and it would say the program had to exit, And in some cases, it just gives you some garbage number. And that's because that number, whatever it represented at some point, it may not have intended to be a number. Maybe it was, some other value of some sort. But it lives in memory right here at where the array size is in the array. It's not really in the array. It's outside the bounds of the array. And we do not have access to this memory location, or we should not have any kind of access to it. Now, if you try to assign that value, you're definitely going to have a problem. But this is garbage data, what we call garbage data. Now, in some programming languages, it's going to just throw an exception, and you're not going to have any data print out. But in this case, we did see some. So what happened is we actually went outside the bounds or the boundary of the array. So this problem that we saw is actually a logic error, and it's called an off by one error. So instead of finishing the index before the array size, we finished within it, and that's not what we should have done. So I changed it back, and now we don't get garbage data this time. Good, excellent. So for the string array, I want to demonstrate another type of for loop that is available since the C++ 11 standard. This is called the range-based for loop. In some languages, it's called a for each loop or an enhanced for loop, like in Java. Instead of using the indices directly, the indexes, we use a syntax that focuses on the elements instead of the index itself. So I'm going to actually comment this out, and I'm highlighting it, and then doing Control-K, Control-C, that highlights the whole thing, and then comments it out. Or I highlighted it and then commented it out. So now I'm going to do for string name colon names, and then I'm going to say print out name, like that. Now, the syntax, I don't consider it a separate repetition control statement. I had mentioned this variation of the for loop in the section on control statements, and specifically the lecture on repetition control statements. However, it's not really a different for loop. It's a variation on the same thing, and it's what we would consider syntactic sugar, meaning that it does not actually change the fundamentals of what's actually going on. It just gives us a nice syntax to work with that makes things a little easier for us. So note with the syntax right here, we can only print out the statements of the array and can't change them without adding special syntax with the ampersand, so the and sign, which would make the string a reference. Then we could actually change it. But that's outside the scope of our discussion right now, but we will talk about references later in the course. So let's print this out and see if it still works. So I'm saying for every name that's inside the names array, notice I'm not using int here because I'm not interested in the index. I'm interested in the actual type of the data that lives inside this. So you can read this out loud as in. So string name in names, and every time it iterates, it actually automatically goes to the next name until it's done. So with this type of loop, you actually can't go out of bounds. So it's very useful. You'll notice that it is actually printing out the names just like we had before. Excellent. Also note that you could use the C++ keyword auto to let C++ infer the data type of the elements based on the array that we have declared. So we could actually do this. Instead of using string, you can tell C++, yeah, figure it out yourself. And it will figure it out for itself. It will say, hey, I know names is an array of strings, so let's print out names. And it does exactly the same thing, right? So Bob, Sally, John, and Ed. Now, I want to issue a challenge to you. So I want you to create a project called More Array Fun and use a regular for loop to populate an array of integers of size 10 with the numbers 1 through 10 inside of it. It should be much shorter than doing it by hand. Then, in a separate range-based for loop, I want you to print out the elements of the array you just populated. So, pause the video and see if you can accomplish this little challenge. Did you complete the task? Let's do it together. Create a project called More Array Fun. So I'm going to close this project. I'm going to create a new project, empty project, called More Array Fun. Then I'm going to, of course, create our little C++ file here, main.cpp. I'm going to give us a little skeleton here. All right. And then what we're going to do is I'm going to have an array called SumArray. So the idea is that we were to populate an array of size 10 with the numbers 1 through 10. So it should be an integer array. So I'll call it SumArray. Could name it something else if we wanted to. Size 10. There we go. We're supposed to use a regular for loop to initialize this. For int I equals 0, I less than, and let's actually change this right here. I'm going to say const int array size equals 10. Let's use this. This is a little bit cleaner because I have to keep using 10 all over the place, and a lot of developers prefer when you have a variable name or a constant name instead of a literal just hanging out all over the place, because if you ever have to change it, if we decide we want size 20, we don't have to change it in 1, 2, 3 different locations or more. We just change it in the one case. The other thing is that it's better self-documenting, meaning the name, I can look at it and say, oh, it's an array size that we're dealing with, not just some number floating there, which we would call in industry a magic number. It just kind of sits there and we have no idea what it's for, unless there's good comments or something else. But it's considered better to use a constant like this anyway, but you could use either. All right, so we are supposed to populate it with the numbers 1 through 10. Well, we have a little bit of an issue. The index starts at 0 and ends actually at 9. That part's fine. We've got the left part fine, but what do we actually set it to? We want it to have, at index 0, we want it to have the value 1. At index 2, at index 0, we want it to have the value 1. At index 1, we want it to have the value 2. At index 2, we want it to have the value 3, etc., etc. So the value we're trying to populate it with is always what? 1 greater than the index. So let's just do that. There you go. Brilliant. That fixes it. And we're supposed to use a range-based for loop to print out the values. There we go. Excellent. So let's run this and see if it works. Good. We just printed out 1 through 10. And we didn't do it just by printing out the values themselves. We actually stored them in an array in one loop and then printed them out in another. Excellent. Great job. In the next lecture, we're going to explore the array class, which is a more modern form of an array that uses object-oriented features, which we'll talk about later in the course. But for now, we're just going to use this modern class to accomplish our goals instead of using built-in arrays, because it has some nice little features that you might enjoy. So I'll see you there.